Here's another video to help you with graphing a line using the slope and the y-intercept.
Mathematicians, in this lesson you are going to learn how to graph lines in slope-intercept form by identifying the slope and the y-intercept. You know that linear equations can be used to show a relationship among number and data and to make predictions. You also know that in the linear function, the rate of change, also called the slope, tells the change in the dependent variable value for every change in the independent variable value. In a linear function, this rate of change is constant. You have seen the slope written as the change in y over the change in x. You also know that linear functions cross the y-axis and that this point is called the y-intercept. It is also sometimes referred to as the initial value because that is the value of the dependent variable when the independent variable is 0. In other words, it tells us what y is when x is 0. You have learned to take information that is linear and write it as a linear equation in y equals mx plus b form, where m represents the rate of change or slope, and b represents the initial value or y-intercept. Now we will use that information to graph lines in slope-intercept form. I'm going to explain this idea by showing you an equation in slope-intercept form. To graph the equation y equals 4/5 x minus 7, we identify the slope as 4/5 and the y-intercept as -7 because this minus 7 really means that this 7 is negative. Because we know that y is -7 when x is 0, we put a point at -7 on the y-axis. The slope 4/5 means that there is a change of 4 units in y for every 5 units in x. To graph this, we go up 4 units and over 5 units on our coordinate plane and put another point at that place. We want to do the same up 4 over 5 movement again to place a third point. Then we can join the 3 points in a line. Once we have this line, we can use it to determine a y value for any given x value. In this case, if we want to find out what y will be when x is 10, we go to 10 on our x-axis and look at the line to find what is the corresponding y value. In this case, when x is 10, y is 1. This shows a positive slope. In our next example, y equals -3x plus 6, we have a negative slope. The slope is negative because x has a negative coefficient, in this case -3. We know that the y-intercept is 6 and put a point at 6 on the y-axis. The slope of -3 means that for every increase of 1 for x, there is a decrease of 3 for y. We are used to seeing this as a fraction, so we can write -3 over 1 if that is easier to visualize. From the point of 6 on the y-axis, we count down 3 and over 1, put a point, down 3 and over 1, put a point, and connect the points with a straight line. If we want to know when y will be 0, we can look at the point on the x-axis, where the line crosses the x-axis, and find that it is 2. So when x is 2, y is 0. Let's see how this works in a problem. Suppose a balloon is descending from a height of 200 feet at a rate of 20 feet per minute. When will the balloon reach the ground? This function is modeled with the equation y equals -20x plus 200. We can graph this by putting a point at 200 on the y-axis and counting down 20 and over 1 for our next point. Once we join those points in a line, we can extend the line to see that the balloon will hit the ground in 10 minutes. So now you know how to graph lines in slope-intercept form by identifying the slope and the y-intercept.